2, linear modeling. So in Algebra 1, we did a lot with the linear modeling where you had a word problem and you had to come up with the equation to go with it and solve a problem. We were using constant slope or constant rate of change and a starting value. And we're going to continue to do that here today. So exercise 1 says Jay was driving away from New York City at a constant speed of 58 miles per hour. He started 45 miles away. So we're going to start out here with a constant speed of 58 miles per hour, and he started 45 miles away. So right off the bat, we need to remember a few things. We need to remember our slope-intercept form, which is y equals mx plus b. Remember where m is your rate of change, and b would be your starting value, your y-intercept, your constant. So we're going to say starting value. And then it says to write a linear function that gives Jay's distance d from New York City as a function of the number of hours h he has been driving. So that just tells me I'm writing a linear equation in slope-intercept form, but instead of y, I'm going to be using d, and instead of x, I'm going to be using h. So first off, I'm going to have d equals, and I'm looking for my constant rate of change. And remember, per is the key term there. So it's going to be 58h. And we know that Jay is driving away 45 miles. So he started 45 miles away from the city. So it'd be plus 45. Now it says if Jay's destination is 270 miles away from New York City, algebraically determine to the nearest tenth of an hour how long it will take, it should say Jay, to reach his destination. So I have it 270 miles away. That's the total amount, the distance away. So we're going to plug that in for D. So I'm going to have 270. Let's try this again. 270 equals 58h plus 45. And I'm just solving for h here. So I'm going to subtract 45 from both sides. And I would get 225 equals 58h. Put my screen a little bit. Then divide both sides by 58. And I'm going to have 3.9 hours. Remember, it says round to the nearest tenth. Now, in exercise 1, it is clear from the context that both the slope and the y-intercept, it is clear what they were. Although this is often the case when constructing linear models, sometimes the slope and point are known, in which case the slope form of the line is more appropriate. So this is just telling us right now that we're going to be using the point slope form. Takia is trying to model her cell phone plan. She knows that it has a fixed cost per month, along with a 15-cent charge per call she makes. In her last month's bill, she was charged $12.80 for making 52 calls. So the first thing is to create a linear model in point slope form for the amount Takia must pay, P, per month, given the number of phone calls she makes, C. So remember, our point slope form is y minus y1 equals m times x minus x1. Well, in this case, what we're going to be doing is plugging in p and c instead of y and x. So you're going to have p minus p1 equals m times c minus c1. Now let's look at this. We know what our slope is. It tells us 15 cents per call. So my slope is going to be 0.15. And then my point that I'm going to be using is 52 calls, because that's my input, so that'd be my X or my C in this case, so 52. And then my output would be $12.80, because when I call 52 times, my total bill is $12.80. Now I'm just going to set up the formula. So I have P minus $12.80 equals 0.15 times 52 minus C. And that's your answer for A. B says, how much is Takia's fixed cost? In other words, how much would she have to pay for making 0 phone calls? So 0 phone calls means that the C is going to equal 0. So you can solve for P to start with in this equation and then plug in 0 for P and solve for C, or you can just plug in 0 right away and solve for P. That's what we're going to do. I have P minus 1280 equals 0.15 times 52 minus 0. So I have P minus 1280 equals 0.15 times 52, which would give us P minus 1280 equals 780. And my apologies, I made a mistake up here. We go back and correct something right here. It should have been C minus 0. So, excuse me, C minus 52. I said 52 minus C. And then we'd have 0, plug the 0 in for C right there. And so it'd be negative 52 here, which makes that a negative. So then I'm going to add 1280 both sides. I apologize by that mistake. And so my P is going to be $5. So that means our fixed rate is $5. This is where we're going to be getting into the calculator use. So we need to make sure you have your graphing calculator and paying attention. Many times linear models have been constructed and we are asked only to work with these models. Models in the real world can be messy and it's often convenient to use our graphing calculators to plot and investigate your behavior. So we're first going to look at exercise 3. It says a factory produces widgets, generic objects of no particular use. The cost is C in dollars to produce W widgets, and it is given by the equation C equals 0.18W plus 20.64. Each widget sells for 26 cents. Thus, the revenue gained from selling the widgets is given by R equals 26 cents W. So this seems like a lot to just look at right now. We're just going to break it down. So first it just says use your graphing calculator to sketch and label each of these linear functions for the interval 0 is less than or equal to W is less than or equal to 500. Be sure to label your y-axis with the scale. What this is telling you is that we're going to take and we are going to graph these two equations, and we're going to do that on a graphing calculator. So you're going to pull up your graphing calculator and you're going to hit on, new document, add graph. You have your first function here, and that is C equals 0.18W plus 20.64. So what we're going to do here, you're just putting your y, your f of x is y, or C in this case. So 0.18x plus 20.64. And you're going to hit enter. Notice you don't see that on the screen, and that's okay because we're going to fix that in just a minute. But you're going to hit tab to put the next equation in, which is going to be 0.26x. Hit enter. So now we're going to go to our Control T to get the split screen of the table. And we know that our constraints or interval is 0 is less than or equal to W, which is less than or equal to 500. So that means that I'm going to go from 0 to 500. So I need to change my table settings, edit table settings, and I'm going to go from 0, and I'm going to go up by 50 because I'm going to 500. And as you can tell, it changes. So 0, 500, 100, 150, 200, and so on and so forth. So I know I'm going to 500, and at 500, that my Y for each thing, right here, 500, my Y is, for my first equation, is 110.64, and my second equation is 130. So this is going to help me determine what to set my window for. So I need to get rid of that. I'm going to write down 130 to help me remember. I'm going to go back and I'm going to get rid of that table because we don't need to see. So remove table. And then we're going to go to menu, window zoom, window settings. My X, we're starting at 10. And we're going to go to 500 because that's what was given to us in the problem. Then my Y, again, we're going to start at 0. And we're going to go to, it said 130 is the highest, so we're just going to go a little bit above that and go to 150 and hit OK. And now you can see where these two graphs are on the same window. And now I can also determine, that's all we need right now to determine how to sketch the graph. So we're just going to sketch this. You can use, go back to your table and use your points that way. So we're going to go back here and we're going to sketch it. So from the top, I have my top point is 150. This is 0. This is going to be 500, remember? And then I'm just graphing. So my R equals 0.26W is going to just kind of go up like this. And then I'm going to label that as R equals 0.26W. I'm going to change colors here. And then the next one, I know my y-intercept, my starting point was 20.64. So I'm just going to kind of gauge where that is. And it went somewhere like this. And so then I'm going to label that as C equals 0.18W plus 20.64. Again, this is just gauging. It says sketch and label. So sketching, it's not going to be an extremely accurate thing, but I am going to put 20.64 at this point just so that we know that's what that is. And then when we go farther down, it says use your calculator's intersect command to determine the number of widgets W that must be produced for the revenue to equal the cost. So this is telling us to find the intersection. So we're going to go back to our calculator here, and we need to find the intersection. So you're going to go to menu, analyze graph, intersection. Here it says lower bound, so you're going to go just to the left of the intersecting, and then upper bound is just to the right. And it tells you right here it intersects at 258.67.1. So that tells me, going back to here, that you have to sell, or I have to sell 258 widgets. This was my intersection point right here. And I had to sell 258 widgets in order to produce the revenue equal to cost, so to break even. Now it says that the profit is defined as the revenue minus the cost. Create an equation in terms of W for the profit P. So this just is a little bit different, and we're going to go here. Let me scroll down, or extend that rather. There we go. So what I'm going to do is I have my profit is equal to the revenue minus the cost. So we were given those things above. So I have my profit is equal to my revenue, which is 0.26x, minus the cost, which was 0.18x minus, or W. So we need to use, let me start that again, because we do need to use W, because it is in terms of W. So it'd be 0.26 W minus 0.18 plus 20.64. So I need to distribute that negative into everything inside the parentheses. So I'm going to have 0.26W minus 0.18W minus 20.64. That's a minus right there. Then when I combine like terms, I have my profit is going to, equation is going to be 0.08W minus 20.64. There's your answer. So D says, using your graphing calculator, sketch a graph of the profit over the interval 0 is less than or equal to W is less than or equal to 1,000. So selling 0 to 1,000 widgets. Use a table on the calculator to determine an appropriate window for viewing. Label X and Y intercepts of this graph. So the very first thing we are going to do is just graph that last equation, which was P of W equals 0.08W minus 20.64. So we're going to go back up to here. We're going to get a new graph. So on new document, you're not saving it, add graphs, and it's going to be 0.08x minus 20.64, because that's the profit. Enter. Again, it's not on there, so we need to look to see what our table is going to be. So I'm going to go Control T, if I can get it, there you go. And then I'm going to go Menu, Table, Edit Table Settings. I know that my X starts at 0 and it goes to 1,000, so I'm just going to make that my step to of 100 because 1,000's a lot. Enter. So I know at 0 my Y is negative 20.64, and then at 1,000 I have 59.36. So when I go to my window, I'm going to probably do negative 27 to probably a good number would be 60. So now I can get rid of this graph, or this table rather. I'm going to go to Menu, Window, Zoom, Window Settings. My X is 0 to 1,000. That was what was given. My Y, remember we're going to do negative 25 to my max was 60. I'm actually going to change this to negative 30 just so it's a nicer number. Okay. And so I have my graph right here. So the first thing we have to do is just sketch that graph. And if I need to determine an easier way to determine what right here my X or my X-intercept is, I can go back to my table, Control T, and I can go when my Y is 0. So you're going to go up. You can just keep scrolling. There's easier ways to do this, I know, but so when my Y is 0, my X is 258. So this kind of just tells you how to graph it. So when I'm going back here, I'm going to have my dollars. My highest dollars is 60. And then the lowest down here was going to be negative 30. Remember, that's my starting point at negative 20.64. And then this is going to be 1,000. And remember, this is 258 right here because that's where it crosses. And so then you're just going to sketch the graph that goes like this. And then you're going to write it as PW equals 0.08W minus 20.64. That's D. And E says, what is the minimum number of widgets that must be sold in order for the profit to reach at least $40? So that means the profit, the P of W is going to equal 40. So I'm going to go back to my calculator. I'm going to get rid of that table right there. And then I am going to actually add one more equation is going to be 40. F of x equals 40. And so then you can see where the intersection is. So we can go to menu, analyze graph, intersection, lower bound, upper bound, and it says 758.40. So if I go right here, let's say this is 40, that point right there is 758.40. So that means I would have to sell 758 widgets to make a $40 profit.